In this video, we're going to look at solving quadratic word problems. Suppose a rectangle has an area of 176 centimeters squared, and we know that one side is 5 centimeters longer than the other side. We want to know the dimensions of the rectangle, in other words, the length and the width. Well, we know that the area of a rectangle is length times width. So what we're going to do, we picture this rectangle, and we know that the area is 176. So what that really kind of means is that we can say we've got the length here and the width here. We can reverse those two, it doesn't matter. So we'll say we've got the length along one side, the width along the other, and that length times width is 176. Well, let's let x be the length. Well, if x is the length, then we know that one of the sides is 5 centimeters longer, then that means x plus 5 will be the width, because x plus 5 is 5 longer than x. So instead of saying 176 equals x times x plus 5, we can now say, because that is the length times the width, we can distribute that x in and say 176 is equal to x squared plus 5x. And now we can bring that 176 over to the other side, and we can say 0 is equal to x squared plus 5x minus 176. Now, what we're going to do is see if we can think of two numbers that add to 5 and multiply to negative 176, or if we prefer, we can use the quadratic formula. Well, two numbers that meet that condition of adding to 5 and multiplying to negative 176 are positive 16 and negative 11. So 0 is equal to x plus 16 times x plus 11, meaning x plus 16 is equal to 0, or x minus 11 is equal to 0. Well, if x plus 16 equals 0, x is equal to negative 16. And if x minus 11 is equal to 0, x is equal to 11. Now, x, if you recall, represents a length, so it can't be negative. So there's no way x is negative 16. So therefore, we can say x is 11. And remember, the width is going to be 5 centimeters more, so the width will be 16. So to answer the question, what are the dimensions of the rectangle? The answer is 11 centimeters by 16 centimeters. Now, what if we have the sum of the squares of two consecutive positive integers is 265? We want to know what the integers are. So just to explain what that means, if I said I had a couple of integers, one was x and one was y, if I then said the sum of the squares, I would be talking about x squared plus y squared. So what we're saying is x squared plus y squared is 265, but y is an integer consecutive to x. Consecutive means the next one. So if one of the positive integers is x, the next one is really x plus 1. It's just the next integer. So this means x squared plus x plus 1 quantity squared is 265. Okay, so again, consecutive means we're going to the next one in the list. So if we're talking about integers, we're adding 1. Okay, so that's what we write here. The two consecutive integers are x and x plus 1. The sum of the squares of the two consecutive integers is therefore x squared plus x plus 1 quantity squared. We know that that's equal to, it says 265 there. It says 263 on our sheet. We'll see which one of these is correct. It actually should say 265. Little typo there. Okay. So now, what that means is x squared plus x plus 1 quantity squared is 265. We expand out x plus 1 quantity squared. And when we do that, we get x squared plus x plus x plus 1. We get that right here. And that's equal to 265. We can collect up our x squared plus x squared to get 2x squared. We can collect up our positive x plus x to get positive 2x. Subtract 265 from each side, we get negative 264. All of that equals 0. Now, looking at that most recent line that I've marked up in red, we see we can common factor out a 2. And then we can use our standard methods of trinomial factoring to see that we can say that really factors to the quantity x plus 12 times the quantity x minus 11. That means x is either negative 12 or positive 11, because we're either saying that x plus 12 is 0, or we're saying that x minus 11 is 0. And if x plus 12 is 0, then x is negative 12. And if x minus 11 is 0, then x is 11. Okay? Now remember, the integers in the question, it said they were positive. So that means x is 11. And the way we stated our solution at the start, the second one was x plus 1, so that means it's 12. And so therefore we can say the two integers are 11 and 12. Now just to clarify what this question was asking, just in case it's still a little confusing, we agree that 11 and 12 are consecutive integers, one after the other. And we agree that 11 squared plus 12 squared is 121 plus 144, which is 265. So what we did is we found two consecutive positive integers, 11, 12, where if we squared them both and then added that, we would get an answer of 265. Now, what if we say the sum of the squares of four consecutive positive even integers is 504? We want to know what the integers are. Well, you might be tempted to say, well, that just means x squared plus x plus 1 squared plus x plus 2 squared plus x plus 3 squared is 504. And this would be close. I certainly agree with you that what you've got there are four consecutive integers. But we want four consecutive even integers, four consecutive positive even integers. Think about even numbers. We go 2, then we go 4, then we go 6, then we go 8. In order to have consecutive even integers, we must be adding 2 each time. So if we start with x, the next one's x plus 2, then the next one's x plus 4, and the next one's x plus 6. So we're actually going to want to change this because of that circled word even. We're going to want to change it to look like this. That'll be our initial line of our solution. Okay? And same would work if it was odd integers. If it was odd integers, even still, the numbers 3, 5, 7, 9, we're still adding 2 every time. So just like we said on the previous slide, our initial equation is going to be the one with the arrow pointing at it. X plus 2 quantity squared is just going to be x plus 2 times x plus 2. X plus 4 quantity squared is going to be x plus 4 times x plus 4. And x plus 6 quantity squared will be x plus 6 times x plus 6. So we'll have our x squared here. Our x plus 2 times x plus 2 will be x squared plus 4x plus 4. Our x plus 4 times x plus 4 will be x squared plus 8x plus 16. Our x plus 6 times x plus 6 will be x squared plus 12x plus 36. All of that's going to equal 504. So all we're going to do now is just collect like terms. We've got 4x squareds. Then we have a 4x, an 8x, and a 24x. So that'll be 24, and a 12x, sorry. So that'll be 24x. And then we have a 4, a 16, and a 36. So that'll be, I think, 56. And all of that will equal 504. And now we'll be able to solve that quadratic. Okay, and that's what we show on the next line there. So we have this line, like I said a moment ago, we want to set it equal to 0, so we're going to subtract 504 from both sides. When we do that, we get 0 on the right and negative 448 on the left. Now, that line with the check mark next to it, that equation, we see on the left side an opportunity to factor out a 4, and we get x squared plus we get x squared plus 6x minus 112 right here after we factor out the 4. Well, that's equal to x plus 14 times x minus 8. So what this means here, this line with the arrow pointing next to it, that means x plus 14 is 0, or it means x minus 8 is 0. Well, that's another way of saying either x is negative 14 or x is positive 8. Okay? And there we go. But remember, we were talking about positive even integers, so that means x is 8. So we have our answer for x. Now, go back a few slides, we said our integers will be x and x plus 2 and x plus 4 and x plus 6. So if x is equal to 8, then our integers are really 8, 10, 12, and 14. Those are consecutive positive even integers, and we're saying the sum of the squares is 504. And if we feel like double checking our answer, this is what it's saying. 64 plus 100 plus 144 plus 196 does indeed equal 504. So it actually checks out correctly. Now, this next question tells us that a right triangle has a base 7 centimeters less than 3 times the height. Okay, so let's think about that for a second. 7 centimeters less than 3 times the height. Now, the area of the triangle is 20 centimeters squared. So what we're going to do, we're going to picture this right triangle. Okay, now we have a height. The base, this part right here, I haven't drawn a good triangle. It's not drawn to scale. But the base is actually 3 times the height. But then it's 7 centimeters less than that. So it's actually 3h minus 7. So we have a right triangle with a height of h and a base of 3h minus 7. And we know that for triangles, area is always 1/2 base times height. So 1/2 base times height, this formula that I'm circling, is really 1/2 times the base is 3h minus 7, the height is h. Okay? We also know the area to be 20. So really what this is saying is the area of 20 is equal to 1/2 times 3h minus 7 times h. Okay? So what we'll do from this line here, I know it got a little sloppy, but let's multiply both sides by 2. If we multiply the left-hand side by 2, we get 2 times 1/2 and then 3h minus 7 and then h. And if we multiply the right-hand side by 2, we get 2 times 20. Now, what we can do is say 2 times 1/2 is actually equal to 1, so it kind of cancels out. And we have 3h minus 7 times h. And on the right-hand side, 2 times 20 is equal to 40. So that's what we have written here. We're now going to distribute in the h on the left-hand side. So we get 3h squared minus 7h equals 40. That means 3h squared minus 7h minus 40 equals 0. That means 3h plus 8 times h minus 5 equals 0. We factored out the left-hand side. Quadratic formula also would have worked there. Now, once we have that last line, that means either 3h plus 8 equals 0 or h minus 5 equals 0. Well, if 3h plus 8 equals 0, then that means 3h equals negative 8, and h equals negative 8 over 3. If h minus 5 equals 0, that means h equals 5. So on first glance, we say either h is negative 8/3 or h is 5. But obviously, the height of a triangle is not going to be negative, so we can call that extraneous, which means, in this context, no good. And that means h is 5. Now, the base is 7 centimeters less than 3 times the height. So that means it's 7 less than 3 times 5. Well, 3 times 5 minus 7 is 8. So what's happening is we have a triangle with a height of 5 and a base of 8. It's a right triangle. And the area is 20. And that actually makes sense because 1/2 base times height would be 1/2 times 8 times 5, which in fact is 20. Okay? So therefore the height is 5 centimeters and the base is 8 centimeters. Now, what if JoJo has a lawn that's 50 meters by 40 meters? She builds a sidewalk of uniform width around the lawn and leaves a patch of grass in the middle with an area of 1,344 meters squared. We want to know the width of the sidewalk. So the original area is 50 by 40. So 50 by 40 is her backyard. And the area of 50 times 40, real easy math, 50 times 40, that's 2,000. So the remaining grass, after she builds a sidewalk of uniform width, the remaining grass, the part I'm shading it in red, is 1,344 meters squared. Okay? So since it's a uniform width, we've got 1,344 in the middle. A uniform width, what we're going to do is we're going to say let that uniform width be x. Uniform width means it's the same all the way around. Okay? And we're looking for what that width is. Now, let's think about this. If I have a length of 40 across the top, like that, and I cut x off of one side, then what I have left is 40 minus x. But then I cut x off the other side, I have left 40 minus x, or in other words, 40 minus 2x. So what I'm saying is, if the top part, this red thick line that I'm shading, if that's a 40, and I cut x off each side, then this scribbly width is actually just 40 minus 2x. And by a similar way of saying, this height, this vertical line on your screen, will be 50 minus 2x because it's the original 50 vertical minus an x at the top and an x at the bottom. So we have 40 minus 2x there, and we have 50 minus 2x there. So since we have a 40 minus 2x and a 50 minus 2x as the length and width of the rectangle, and since the area of that rectangle is 1344, we can say the area of the lawn is 40 minus 2x times 50 minus 2x. We know that to be 1,344, so we just plug that in on the left-hand side, and we distribute the right. 40 times 50 is 2,000, minus 40 times 20x, minus 80x, minus 2x times 50, which is minus 100x. And then this negative 2x times negative 2x is positive 4x squared. Okay, so now what we get on the left-hand side, we've got 4x squared. We've got negative 80x minus 100x, so that's negative 180x. We had plus 2,000, but now we subtract 1,344, so we have plus 656. And so we can say 0 is equal to 4x squared minus 180x plus 656. Now, what that then means is that we can common factor 4 out, and we're left with x squared minus 45x plus 164. Two numbers that add to negative 45 but multiply to positive 164 are negative 4 and negative 41. So 0 is equal to 4 times x minus 4 times x minus 41. Well, that means either x minus 4 equals 0, meaning x equals 4, or it means x minus 41 equals 0, meaning x is equal to 41. Okay? So it's either 4 meters or 41 meters. That's what this first sentence says. But now let's use our thinking caps. There's only 40 meters up top. We can't possibly have a sidewalk of 41 centimeters when there's only 40 meters up top. And in fact, we actually want two of them. So there's no way we could have 82 meters worth of sidewalk when there's only 40 at the top and when there's only 50 on the side. Okay? So clearly 41 is extraneous. That means the width of the sidewalk is 4 meters. And so just to show you what that means, all it's saying is, the whole question is just saying this. We started off with 40 times 50, 40 by 50. But JoJo then put a 4 meter sidewalk around the whole thing. So since she had 4 on all, since everything was 4, that meant that this across the top was now only 32, and this piece along here was now only 42. Well, 32 times 42 is equal to 1,344. So that's the ultimate thing that we just did. Now, what if Scotty has a rectangular picture with a length of 30 centimeters and a width of 20 centimeters, and there's a frame of uniform width around the outside so that the total area, including the picture and the frame, is 816 centimeters squared. We want to know how wide the frame is. So this question's a little bit different. This one is, the last one was telling us the dimensions of the outside and the area of the inside. This one is giving us the dimensions of the inside and the area of the outside. But basically what's happening is here we have a picture frame. We've got 30 centimeters and we've got 20 centimeters, so that part's easy. He puts a picture frame around it. It's supposed to be uniform. I didn't do a very good job drawing that, but the width is the same all the way around. And what it's saying is that this longer length times this longer width is going to equal 816. Okay? And very similar to what we just did, we're going to say, okay, we're going to let that uniform width be x. And so this longer length here, this vertical one, I'm going to call that 30 plus 2x. And then this longer horizontal length, I'm going to call that 20 plus 2x. And when I multiply these two quantities together, I'll get 816. Okay, so here we go. Going back over it again, we've got the 20 and the 30. X is all around. So that means the vertical one is 30 plus 2x. Because again, it's the original 30 plus an x and another x, making 30 plus 2x. And the other one, the horizontal one, is a 20 across plus an x and an x, making it a 20 plus 2x. Okay? So that means the total area is 30 plus 2x times 20 plus 2x. But we know that the total area, including the frame, is 816. So that means 816 is equal to 30 plus 2x times 20 plus 2x. We expand, 30 times 20 is 600, 30 times 2x is 60x, 2x times 20 is 40x, and 2x times 2x is 4x squared. So now we can collect up the 60x and the 40x, and that'll leave us with 100x. We have the 4x squared. And now we have a positive 600. When we subtract 816 from both sides, we'll be left with negative 216 as our constant term on the right and 0 on the left. We can common factor out a 4. And when we do that, we'll have a trinomial of x squared plus 25x minus 54. And then we'll be able to say that we've got 4 times x plus 27 times x minus 2. Okay? Now, that would mean x is either equal to negative 27 or x is equal to positive 2. Now, we're talking about a width of a frame, so x equaling negative 27 is extraneous, so therefore the simple answer is x equals 2. The width of the frame is 2 centimeters. So once again, just to show you what we're saying there's an original picture that's 20 by 30, and we add 2 centimeters all the way around. When we add 2 centimeters, both sides horizontally and both sides vertically, this top piece is 24, and this side piece is 34. And then we're saying 24 times 34 gives us our area of 816. Now, in this question, we've got a ball launched off a cliff, and it follows a certain trajectory and a certain equation, and we want to know when the ball reaches a particular height, and then we want to know how long the ball is above that height. All right, well, if the ball has a height of 548.8 meters, that means we can just sub 548.8 in for h. So we do that right at the start. So in the first line, we just re-express the equation with 548.8 put in for h of t. Now what we're going to do next, we're going to subtract 548.8 from both sides. So we have 0 on the left and then this expression on the right. We see an opportunity to common factor. Now if you don't see that opportunity, keep in mind that usually it'll work out that way in these questions that you can common factor out that decimal. But even if you didn't see that, the quadratic formula would still work. But in this case, if we divide negative 4.9 from negative 4.9t squared, we're left with t squared. If we divide negative 4.9 from positive 58.8t, we're left with negative 12t. And if we divide negative 4.9 from negative 132.3, we're left with positive 27. So we have a trinomial factor. Two numbers that multiply to negative 12 and add to 27 are negative 3 and negative 9. So we can factor this out and say 0 is equal to negative 4.9 times the binomial t minus 3 times the binomial t minus 9. That means t minus 3 might equal 0, which means t is 3, or t minus 9 might equal 0, which means t is 9. So let's think about this for a second. We've got a cliff, a ball's launched over the side. We are asking when it reaches a height of 548.8 meters. And it actually kind of makes sense that we get two answers here. So we don't have an extraneous answer. We actually have legitimately two different answers because it reaches that height on the way up, and then it gets to its max, and then it comes back down. It reaches the same height again. So legitimately, the answer is 3 seconds or 9 seconds. Now, we want to know how long it's above that height. So again, let's go back to that diagram. We have a cliff, we have a ball going up, we have a height that we're asking about, which is, let's say, 548.8. Well, if it reaches a certain given height at a time of 3 seconds, and then it keeps on rising and then falls, and it reaches that same height again at a time of 9 seconds, in between those two times, it was actually above that height. So 9 minus 3 is 6. And so the ball was above the height requested for 6 seconds. Now, we've got this young lady named Kayla, and she's selling t-shirts. She knows if she charges $25 per shirt, she can sell 1,500 shirts. She knows for every additional 50 cents she charges, she'll sell 20 fewer shirts. We want to know what the price would be if she made a revenue of $38,340. Well, we did questions kind of like this when we were doing maximum and minimum questions. This isn't one of those, but let's take a shot at it. First, what we're going to do, very similar to how we learned in a previous video, we're going to say that the revenue is the price of a shirt times the number of shirts sold. Now, the baseline price of a shirt is $25, and the baseline number of shirts sold is 1,500. She'll increase the price by 50 cents X times, and she'll therefore lose 20 customers X times. So her revenue will equal 25 plus 0.50x times 1,500 minus 20x. Well, when we expand that out, 25 times 1,500 is 37,500. 25 times negative 20x is negative 500x. 0.50x times 1,500 is plus 750x. And 0.50x times negative 20x is negative 10x squared. When we then rearrange and collect like terms, we get 0 is equal to this expression here. We can then common factor out a negative 10, and we're left with x squared minus 25x plus 84, and that would mean that x could either be 21 or x could be 4. Now, neither of those is an extraneous answer. It's possible that she recall that the price of a shirt in our example was equal to 25 plus 0.50x, and recall that the number of shirts sold in our example was 1,500 minus 20x. Well, what we're saying here is it's possible for x to be 21. If x is 21, then the price will be 25 plus 0.50 times 21, which ends up equaling 35.50. And the number of sales will be 1,500 minus 20 times 21, which would be 1,500 minus 420, which would be 1,080. And so if you make 1,080 sales and each one is $35.50, your revenue will be 38,340 as shown in the question. Right there. And similarly, if instead of letting x be 21, if you let x be 4, then the price of a shirt would be 25 plus 0.50 times 4, which is 27. The number of sales would be 1,500 minus 20 times 4, which would be 1,420. 27 times 1,420 would also give you 38,340. So the answer to the question, what's the price? It might be $27, where x is equal to 4, or it might be $35.50 where x is equal to 21. Neither of those is an extraneous solution. Now, this next question, we say that the perimeter of a right triangle is 80 centimeters, and the length of the hypotenuse is 4 centimeters longer than one of the sides. So we want to find the lengths of all three sides. So check this out. We're going to draw ourselves a triangle, and we're going to say one of the sides is x, and the length of the hypotenuse is 4 centimeters longer, so this is x plus 4. And we're going to say that the last side is unknown. Just for a moment, let's imagine it to be y. Now, on first glance, you might say, okay, we've got two different variables. How can we solve this? But now keep in mind, we know the perimeter to be 80. So since the perimeter is 80, we know x plus 4 plus x plus y equals 80. We can then isolate for y. 80 minus 4 becomes 76, minus x becomes minus 2x. So instead of calling this side length y, we can call it 76 minus 2x. Now we can use the Pythagorean theorem. We know that 76 minus 2x, quantity squared, plus x squared will equal x plus 4 squared. This is just an example like in grade 8 of a squared plus b squared equals c squared. And now we've got a quadratic equation in terms of x that we can solve using either factoring or the quadratic formula. So let's see how this will work as we play it all out. The length of one of the sides is x. The length of the hypotenuse is x plus 4. So this is a repeat. Now in this question here, we'll let the third side be w. We know therefore that since the perimeter is 80, that w plus x plus 4 plus x is 80. So w plus x plus 4 is 80. Isolating for w, we get w is 76 minus 2x. So I'm going to rewrite this as 76 minus 2x. Now, like it says here, the Pythagorean theorem tells us a squared plus b squared equals c squared. C refers to the hypotenuse, and a and b refer to the other two sides. So we're going to be able to say that x plus 4 quantity squared is going to equal x squared plus 76 minus 2x quantity squared. And that's what we get on the next side. And then all we do is we just put 76 minus 2x next to each other, and we distribute. 76 times 76 is 5,776. 76 times negative 2x is negative 152x. Negative 2x times 76 is another negative 152x. Negative 2x times negative 2x is positive 4x squared. Now we still had that x squared at the start. On the other side, we have x plus 4 times x plus 4, which expands out to this. We can now collect the like terms on the left-hand side. X squared plus 4x squared becomes 5x squared. We have minus 152x minus 152x, which is minus 304x, plus 5,776. That's the left-hand side. And that's going to equal x squared plus 8x plus 16. So that this line right here that I'm pointing at with an arrow becomes this other line that I just wrote in red. And now what we did is we have an equation here that I just circled in my handwriting in red. We just subtract x squared from both sides, subtract 8x from both sides, subtract 16 from both sides, and we get this wonderful equation. We see an opportunity to factor out a 4, so we take it. And then we see an opportunity to factor a trinomial or use the quadratic formula. We take it. Okay, we get x minus 30 or x minus 48. So that means x minus 30 is 0, meaning x is 30. Or it means x minus 48 is 0, meaning x is 48. And on first glance, both of those seem like legitimate answers. Okay, the possible side lengths for x are 30 or 48. Now, let's think about it. If x is 30, suppose x is 30. Remember what our triangle looked like a while ago. We said one was x plus 4, and then the other one turns out was 76 minus 2x. If we let x equal 30, then those side lengths are 30, 34, and 76 minus 2 times 30, which is 16. That's a valid triangle. We'll keep it. But now, what if we let x be 48? Well, let's do the exact same triangle. This time we'll do it on this side. If we let x be 48, then this x here is 48, and this x plus 4 here is 52. But the problem is this 76 minus 2x becomes 76 minus 2 times 48, which is negative 20. That's not a valid triangle. So there's only one possible answer here. The 48 answer is actually extraneous. So what we can say is the only possible answer is when x is 30, one of the other side lengths is 34, and one of the other side lengths is 16.